All right, guys, Chavez here. Sorry for the long delay. It's been a while. So I'm going to see if I can start uploading a video every other 2-3 days. And then we'll meet at Zoom and see if anyone has any questions or whatnot. All right, guys, let's get right into it. This is coming from Unit 10. And don't freak out in case you're like, oh my God, I don't know where my Unit 10 packet is, or Chavez never passed it out. Relax. A digital copy can be found on Canvas. So just log into your UT accounts and pull that out. All right, guys. So let's go ahead and get right into this. I don't know if you have a sheet of paper to write this down, or if you just want to listen, or if you want a copy of this, give me your email and I'll email you a blank set of notes, or I can post it somewhere or whatnot. So let's get right into it. I hope you remember your experience with logs. This is a review. So here we go. What is a log? A log really is just the inverse of an exponential. So if I tell you y equals log of x, this is called a common log, guys. The base is 10. And then y equals ln of x. This is called a natural log. They're both going to look more or less the same. You have a vertical asymptote at x equals 0. And what did I say? They're inverses of the exponential log. They're inverses of the exponential log. Oh, so funny. So that means this, that if I have y equals, the base here was a 10, so that's like 10 to the power x. And this is just the same thing as saying log base e of x. So that one is like e to the power x. And since they're inverses of each other, it's going to look like this. If this point here is 1, 0, then that point there is 0, 1. And this one has a vertical asymptote at y. I said vertical asymptote, but it's horizontal. This has a horizontal asymptote at y equals 0. As you can see right there, guys. So if I wanted to do another point, if I want to be definitive here and put another point, if it's log base 10 of x, I have another point at 10, 1. So I'm going to say that's 10, 1. If so there it is. So if I have ln of x, you have another point at, let's see, at e, 1. So what I mean by that is, here's a property, log base 5 of 5 is going to equal 1. So if I had log base 5 of x, I'm going to have another point at 5, 1. So hopefully that made sense. So I guess I should talk about graphs right here, guys. So if I have y equals log base, I'm going to call it base 5. If I call this log base 5 of x, that means one coordinate for sure is always going to be 1, 0. I have a vertical asymptote right there, guys. And then remember my property. So if I have log base 5 of 5, that's going to equal 1. In case you're wondering, Chavez, I have no idea how you got 1. It's because of your log properties, guys. Log base b of a equals c. So remember that b to the power c equals a. See? So 5 to what power will give you 5? Well, 5 to the power 1. So if I say log base 5 of x, I know I have another point at 5, 1. And since I have a vertical asymptote at x equals 0, it will look something like this. My domain and range, notice that your domain is restricted. So your domain is always going to be all values larger than 0. And your range is, since I go down forever and I go up forever, it's a slight angle, but it does go up forever. Your range is all real numbers. All real numbers. And of course, if you shift, that's going to mess up your relationship there. So what is the inverse of this function? Well, the inverse of that function is your exponential function, which is going to be y equals 5 to the power x. So how's that going to look? Well, I'm going to have a point at 0, 1. And then since that was 5, 1, that means 1, 5. I'm going to have a point at 1, 5. And it's going to look like this, guys. So what is the domain and range for this exponential? Well, my domain, notice I go forever to the left and I go forever to the right. So my domain is going to be all real numbers. I'm going to put hashtag, that stands for numbers this time. Or I could use the bold R. That stands for all real numbers as well. And by my range, notice that I approach the y value of 0, but it's actually never going to touch. If you were to say limit as x approaches negative infinity, you would say 0. But we're not talking about limits here. We're just talking about what the range is. So the range is all values larger than 0. Cool, guys? Cool. And if they were to ask you for end behavior, you would say as x approaches negative infinity, f of x approaches 0. And you are going to have questions like that on Delta Math. So hopefully you remember how to do it. If you guys have issues, we'll talk about it in our Zoom, and maybe we'll make another video on that, guys. All right. Hopefully you notice. Let me go ahead and draw. Notice that if I reflect across that black dotted line, that blue line would turn into that red line, and vice versa, guys, because exponentials and logs are inverses of each other, guys. So hopefully that's starting to make sense to you guys. And then I write so translations. So what if I have something like this? Let me go ahead and get rid of this because it's too sensitive right now. All right, y equals a log some base, and then x minus h, close it, plus k. So what happens there, guys? That a there in front, I mean, I guess you can use your power rules and put it in here, but because I put the h, I'm going to leave it alone. That a is a vertical stretch or compression. Stretch or compression. This h is a horizontal shift. And this k is a vertical shift. Same thing, guys, for exponential functions. So here's an exponential function, a times b to the power x, and I'm going to put a parenthesis minus h, close it, plus k. This a is a vertical stretch or compress. This h is a horizontal shift. I'm just going to go ahead and put the arrow there. And then this k is a vertical shift. Now, I do got to mention something, guys. So if I have something like, I'm going to say b to the power x, if my b is bigger than 1, it's going to look something like so. If my b is larger than 1. If your b is between 0 and 1, then it's going to look something like that. And the reason for that, guys, don't be a robot. Yes, you can probably just memorize that. But think about it. So I'm going to look at two specific functions. Don't write this down. Well, I guess you can't write it down because right now I'm just talking to a laptop. But if you are writing stuff down, just listen right here. And in a little bit, I'll let you write if you want to write. You can just pause it. So look at these functions here. So think about this 2 is obviously larger than 1. And I have to the power x. So think about it. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. 2 to the power 6 is 64. Okay, I'll stop there. So what am I doing? As x gets larger and larger, this whole deal, this whole shebang, the y values just keep larger and larger, guys. So that's why it's going to behave like this function here. And of course, your law of exponents, if I go to the negative, so if I say 2 to the negative 1, 2 to the negative 2, well, all that means is 1 over 2. And this one means 1 over 2 squared. And well, 2 squared is 4. So what happens? 1 over 2, 1 over 4, 1 over 8, 1 over 16, 1 over 32. So as x gets larger and larger in the negative direction, notice that all this is happening, all that's happening, guys, is that my y values are getting closer and closer to 0. This is 0.5, this is 0.25, this is half of 0.25, and even smaller and even smaller. So I hope that made sense, guys. So that's what's happening here. Because now notice, this is half and to the power x. So if I put 1 half to the power 1 is 1 half. If I put to the power 2, well, that means 1 squared over 2 squared, that's 1/4. If I put 1 half to the power 3, that's 1/8. 1 half to the power 4, that's 1/16. 1 half to the power 132. 1 half to the power, the next one, 1, 2, 3, 4, 5, 1 over 32. So you can see what's happening. As x gets larger and larger, I'm looking more and more like this graph right here. And if I were to turn this into a negative exponent, like 1 half to the negative 1, well, 1 half to the negative 1, guys, is just 2. Because all that means is take the reciprocal of this. So that's just your laws of exponents. So I'm hoping that made sense to you guys. about when a graph looks like this one here on the left-hand side and when a graph looks like this one here on the right-hand side. Now, of course, if you make A a negative, well, then all that happens is that your y's turn to a negative value, so you're going to be down here in quadrants 3 and 4. Same thing for this one, guys. If I say A is negative, then it would be in quadrant 3 and 4. But you guys get the gist of that. Oh, okay, or at least I hope. We'll discuss this if for some reason we don't understand. All right, so here we go. Here's a question from Delta Math, and it says, graph this function. So the first thing that I want to recognize, guys, is that this looks a lot like, first I'm gonna draw some stuff here on the right hand side. I'm gonna say y equals a times b to the power x. So here's my parent function, and b is definitely between 0 and 1. So immediately I start looking and I'm like, okay, it's gonna look like that, because this 1/5 is like 0.2. All right, next. So I'm looking at that -7. And remember what I said there, that is a vertical shift. So that means that my horizontal asymptote that was at 0, at y equals 0, right here on this x-axis, is going to go down 7 units. So I'm going to go down to -7, and I'm going to put a dotted line. This is my horizontal asymptote. All right, next. There's two ways to think of this, guys. I think the harder way is probably to see, okay, you're at 0, 1, and then that's a vertical stretch by a factor of 3, so now it's 0, 3, and then I move down, I move to the left 4 times, and then, so I'll be at -4, 3, and then you move down 7 times, so I'll be at -4, 4. So there's a point at -4, 4. I hope you guys understood what I did there. If you didn't understand, then look how simple it is. So what do I want? I want that exponent here. I want this power to be a 0. Why do I want it to be a 0? Because anything raised to the 0 is 1, unless it's a 0 raised to the 0. So if I set, so I'm going to write the equation right here, 3 times 1/5 x plus 4 minus 7. If I set x equal to -4, you will zero out this power, guys. So like I said, anything raised to the 0 is going to be 1. So then you have 3 times, and I'm going to go ahead and write it out as 1/5 for now, to the -4 plus 4 minus 7. Well, this right here is now just, all that thing is just 1. Because this zeroes out, and anything raised to the 0 power is 1. So 1 times 3 is 3, and 3 minus 7 is -4. So there it is. I got a point. My point is -4, -4. -4, -4. Now, I still would have gotten it. I notice that this thing's not perfect. I still would have gotten -4, -4, guys, if you think about it like this. You're at a point at 0, 1. That's from your parent function. And then that 3 makes it vertical stretch by a factor of 3. So 1 times 3 is 3. And then that x plus 4 makes it go 4 to the left. 1, 2, 3, 4, point. And then that -7 makes it go 7 down. 1, 2, 3, 4, 5, 6, 7, point. See, so you still would have gotten it even if you didn't do all that. Cool, guys? Cool. All right, so I know I have 1 point. I need one more. And what you want to do is you want to get a whole number because Delta Math is going to ask you for whole numbers. So let's get a whole number in here. And the way to get a whole number, guys, I noticed that it's 1/5. I noticed that I have a fraction. So I want my exponent to be a -1. Because if I get my exponent to be a -1, I'm going to be taking the reciprocal of 1/5. So that's exactly what I'm going to do right here. I'm going to erase this so I can have some space, guys. And I'm going to set x equal to -5. And when I do that, here's what I'm going to have. Y equals 3, 1/5. -5 plus 4 is going to be your -1 that we want. So here's my -1 that I wanted. 3, 1/5, -1 minus 7. So now the reciprocal of 1/5 is 5. So 3 times 5 minus 7. 3 times 5 is 15. 15 minus 7, what's that? 15, 5, 6, 7 is 8. So I have a point at 8. So I have a point at -5, 8. So I go to -5 and I put a point at 8. And then -5, there we go. And I don't see any mistakes. I think it looks okay. Does it look okay? Yeah, it looks all right. All right, let's go ahead and graph these points here, guys. And it's going to look something like this. And remember, it's supposed to look like this one here. And it does. It looks something like... something like that, guys. Sorry that my graph is not perfect. So we'll show you how that looks like right now in the video. So let's go ahead and let me switch this up so you guys can see the video. All right, guys, here's that same problem that we just had. So it says you must plot the asymptote and any 2 points with whole number coordinates. So notice it says whole number coordinates. All right, so the first thing we said was that -7 means that you're going to have your exponential function shift down 7 times. So that means I'm going to have a horizontal asymptote at -7. So horizontal, all right, there we go. And I just go to -7 and there it is. All right, and then next we said, what did we say? That x plus 4 means horizontal shift 4 to the left. If you think it's easier, you can just zero this out. -4 plus 4 is 0. Anything raised to the 0 is 1. 3 times 1 is 3. 3 minus 7 is -4. So I'm going to have a point at -4, -4. So -4, -4. Bam. All right, so there. And then we said we plugged in the -5 because we wanted to get a whole number here, and we're not even using calculators or anything. And we already did this, so you guys already know what's up. -5 plus 4 is -1. Using your laws of exponents, that means 1/5 turns to 5 to the because 1/5 to the -1 just means, you know, take the reciprocal. So 5 times 3 is 15. And then 15 minus 7 is 8. So I'm going to take this point. I'm going to go to -5, 8. And there it is. I should have everything ready to go. So if I click submit answer, hopefully it likes my answers and bam, check mark. And then of course, there it is. And there it is, guys. So hopefully that made sense. And all right, let's continue. All right, guys, we're continuing along. So let's keep going. So again, this is from DM, from Delta Math, and it says to plot something. So we already know how I have a negative in front of the log, guys. So instead of the log looking like this, so what does that negative do? It pretty much reverses everything. So it's going to look like, it's not going to look like that, right? It's going to look the other way around. It's going to look like this. Because whatever was positive is now negative, and whatever is negative is now positive. All right, so first thing we do, I'm going to look for my vertical asymptote. I know that I have a vertical asymptote. Well, the parent function has a vertical asymptote right on the y-axis. So that makes it shift 8 to the left. So I'm going to have a vertical asymptote at... it's kind of laggy, guys, so it's not being very specific. But I have a vertical asymptote at x equals -8. VA. All right, so next I want to plot a point. So what I want, you can either do one of two things. You know you're at 1, 0, so you could, that's for your parent function. So you can either just move that 8 times to the left, or you can make this expression here a 1, because log of 1 is 0 from your properties. So I'm just going to move this 7 times to the left, 8 times to the left, sorry. 1, 2, 3, 4, 5, 6, 7, 8, and I'm right there. That -2 does not affect it, guys, because remember that's a 0. 0 times anything is going to be 0. Oh, okay. But this 6 does affect it, and you're going to have to move 6 times up. So when I move 6 times up, it's going to be -7, 6. So here's my new transformation. So there it is. And the reason for that is because of the vertical shift, 6 units up. Now, if you don't like that route, guys, you can always remember, here's your side note, you can always remember that log of 1 is always, always, always 0, regardless of the base. It doesn't matter. Now, why is regardless of the base this always equal to 0? Well, think about it. Something raised to the 0 always equals 1. 2 to the 0 is 1. 3 to the 0 is 1. 4 to the 0 is 1. 5 to the 0 is 1. Any number raised to the 0, unless it's 0, is always going to be 1, guys. So that's why you have x-intercept at 1, 0. Because when you plug in a 1, you get a 0. But in this case, since we have that 6 there, it forces up to move us 6. So, Chavez, what are you saying? Just talk to me in English. Here's what I'm saying, guys. That if I write negative 2 log base 4 x plus 8 plus 6, if I were to type in for x value, a negative 7, negative 2 log base 4, negative 7 plus 8, close it, plus 6, this on the inside adds up to a 1. Negative 2 log base 4 of 1 plus 6, all of this zeroes out because log base 4 of 1 is 0. Because log base 4 of 1 is 0, 0 times negative 2 is 0 plus 6, so that's going to give me my y value, see? So what did I put? Negative 7, what's the output? 6. Negative 7, 6. If you thought that was too hard, just do transformations, guys. Move it 8 times to the left, 6 times up, and you are done, 100% done. All right, next. The next thing I would do, you actually have options. You can actually choose several different x values. Since you want a whole number, I want to force this argument on the inside to be the number 4. Why? Because log base b of b is always equal to 1. So log base 5 of 5 equals 1. Log base 4 of 4 equals 1. Log base 7 of 7 equals 1. So I think that's the easiest, guys. So what am I going to do? I'm going to, wait, does it want to erase now? I'm going to force this value, the argument on the inside, I'm going to force that argument to be the same value as the base value. So I have a base value of 4. So I'm going to insert x equals negative 4 because negative 4 plus 8 is 4, guys. So if I do that, let's see, negative 2 log base 4 of negative 4 plus 8 plus 6. Remember, I'm inserting x equals negative 4 into this. So this is y equals, I'm going to get a y value. So y equals negative 2 log base 4 of 4 plus 6. Well, log base 4 of 4, that's just 1. See? So negative 2 times 1 plus 6. Negative 2 plus 6, well, that's just 4. So now I have a coordinate. See, that's a y value. So negative 4, my y value is 4. So I'm going to go to negative 4. 1, 2, 3, 4, negative 4, and then put a point in negative 4, 4. And there it is. That's all I need to complete. So it looks something like that, guys. And I'll show you the video of how we do it on Delta Math. So let's do that right now. All right, here's our next one. Like we said earlier, guys, we already know how it's going to look more or less with that negative there. I have that base 4 plus 6. So that x plus 8, remember that logs have vertical asymptotes. That x plus 8 is going to give me a vertical asymptote at x equals negative 8. So I click on vertical. Here's my dashed line. I go to negative 8. And the easiest way to do this, guys, I want the expression on the inside to be a 1 because log of any base, who cares what the base is, if it's log any base 1, that's 0. As evident because you know that it crosses the x-axis at 1, 0, the regular log. So I want this to be a 1. So what do? I make negative 7. X equals negative 7, just like we did a little while ago. X is negative 7. Negative 7 plus 8 is 1. Log of all that is 0. Log of 1 is 0. So who cares about the negative 2 there? So 0 plus 6 is 6. So 1 point is at negative 7, 6. So right there. All right, and then the next one, what you want to do, you can actually choose from several, but the easiest one, like we stated earlier, is to get the inside expression x plus 8, the argument, to be a 4. And to get that to be a 4, you just make x equals negative 4. So negative 4 plus 4 is 4. Log base 4 of 4 is 1. 1 times negative 2 is negative 2. Negative 2 plus 6 is 4. So what was the x value that we put in? -4. And the y value we get is 4. And there it is, -4, 4. And we push submit, and let's see. See, they're not bad, guys. It gives you some notes here. But look at all the different points you could have chosen. So yeah, not that bad. All right, cool. All right, let's continue on our journey. All right, I already see a typo. Sorry guys, it's because I'm typing this out at 3:30 in the morning. And if you're confused, like, hey, I just saw that video that was at 1. Well, yeah, that's because I was typing out the notes. All right, let's see. I'm asking properties of logs. So log to exponential, exponential to log. So that's pretty straightforward. So if I have log base b of x equals, or let's just use the alphabet, a, b, c, instead of x and y for this one. Log base b of a equals c. If I want to turn that into an exponential, it's going to be b to the power c equals a, and vice versa. So pretty straightforward, nothing crazy. Product rule. All right, so if I have something like log base b of x plus log base b of y, remember they're just like exponents, guys. So when you have something like x to the power n times x to the power y, you're just going to add them up. So it's the same thing with this. So look, there's a plus, so that means I can just write this as log base b of xy. See? And I guess as a side note, if you want to do exponentials here, x to the power n times x to the power n, that's just x to the power m plus n. See, so they work pretty much the same. There's a plus, here's a plus. So I'm adding here, so product there. Cool or not cool? I think it's very cool. All right, quotient rule. Log base b of x minus log base b of y. Or maybe I should have started off with the quotient and then go to this, right? Is the same thing as log base b of x over y. So yeah, so there it is. I have a quotient, x over y, and you can expand it to log base b of x minus log base b of y. And it's the same thing with your exponents. So side note, x to the power m over x to the power n. That's the same thing as x to the power m minus n. That's a subtraction there. I don't know if you can tell. M minus n, and if we zoom in, that's a minus. All right, guys, pretty straightforward. Change of base rule. So I don't know if you want, I do know this, but I don't know if change of base is the right name for it. If you Google change of base, this is what will come out. It's just a property, guys, that you can change any logs into whatever base you want. So if I have log base b of x, and this, so what we're trying to say is that you can just write this as log base a of x. Notice that's a different base, divided by log base a of b. So that's your rule here. And I guess I should be writing I guess I should be writing what ln of e is, or ln of x, not ln of e. Ln of e is just 1, right? So ln of x, which is called the natural log, is equivalent to log base e of x. So that's just something for you guys to know. All right, guys, let's keep going. The equality rule, that just means that if I have log base b of x equals log base b of y, so obviously the bases are the same, log everything's the same, so that means that x equals y. And that's it, guys. So pretty simple properties, nothing crazy. I think most of you guys already know all this, at least I hope you guys do. And if you don't, it's hopefully you've done lots of exponents or similar to that, to your laws of exponents. You can see the similarities. So this is not a proof, guys. This is just flat out just telling you what the properties are. So it's not what I would consider a true lesson. Hopefully your previous algebra teachers have told you how to do those or have shown you a little proof of that. All right, so here we go. So now we're just doing problems because it says, all right, Chavez, show me how to use these rules. So all right, we'll show you how to use these rules. So this one here, I have ln 8 plus ln 7, and it looks like it wants me to transform this into one single ln. So what you're going to do is you're just going to go, all right, that's ln of 8 times 7. And hopefully we know what that is, guys. That's ln of 56. And that's it. You're done. So this one wants to know 36 minus what equals 9. So that's the same thing as saying ln of 36 divided by question mark. So something like this had to have happened. So 36 divided by what gives you 9. So if you said 4, you're correct. So this question mark is just simply ln 4. Or I guess I can circle that and say that's ln of 4. All right, this is your change of base, guys. Notice there's a 7 there. There's a 9 here. So log base 7 of 33 is equal to log base 9. That 9 is arbitrary. I could have chosen any value. I could have said 10. I could have said 12. I could have said 5. But they decided to put 9 in there, so fine. We're going to be stuck with 9. So log base 9 of 33 over log base 9 of 7. Cool? Cool. All right, same thing with this. I guess I didn't mention this in the previous notes. Sorry. No, guys, I do not have the corona. So I have log base b of x. I can also say this does not go under the inequality rule. It goes under the change of base rule. So if I say log base b of x, that's also the same thing as saying ln of x divided by ln of b. So that's something to know. All right, going back to this. So ln of 53 divided by, that question mark is going to be ln of 0.07. So I guess let me write it out completely. Log of 0.0753 is equal to ln 53 divided by ln of 0.07. I don't know why we haven't been putting parentheses, but, I'm putting parentheses. It doesn't matter. I guess it's understood. All right, now let's get to the fun stuff and start doing some algebra here. So I'm trying to solve for x, and it's telling me to solve this. I think we can do it without a calculator. So let's see. The first thing we do, we want to subtract 1 from both sides. So 2 log x minus 3 equals 4. Then I'm going to divide by 2. So then I'm going to have log x minus 3 equals 2. Now it doesn't have a base, guys, so that means my base, it's a 10 because it's a common. It doesn't have a number down there. So this means 10 to the power 2 equals the expression x minus 3. So then that means to get x by itself, I'm just going to go ahead and add 3 to both sides. So x is nothing more than 10 squared plus 3. You can leave it like that, or 10 squared is 100 plus 3 is 103. And then it wants us to check it real quick. So to check it real quick, we just plug in a 103 in there to make sure it works. And it works. Remember, the domain has to be positive here. The argument has to be positive. 103 minus 3 is 100. Log of 100 is 2 because 10 to the power 2 is 100. 10 squared is 100. So 2 times 2 is 4. 4 plus 1 is 5. It works, guys. All right, let's go to the next one. Log base 2 of x plus 3 plus log base 2 of x minus 4 equals 3. So I have a plus here. The logs have the same base. So I'm going to write log base 2, giant parenthesis, and I'm going to write x plus 3, close, open, x minus 4, close, close, equals 3. All right, so hopefully this one won't take too long. Do I have enough space? Oh, yeah, I got plenty of space. So 2 to the power 3 equals the expression on the inside. So I'm going to write 2 to the power 3 equals the expression on the inside, x plus 3 times x minus 4. And no, you don't need a calculator for this, guys. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So I'm going to say 8 equals, and then x squared, and then minus 4x plus 3x. So that's going to be minus x, because the 4 is larger than the 3. And then 3 times 4 is a negative 12. And then I'm going to zero this out, guys. So I'm going to go minus 8 minus 8. And I'm going to go 0 equals x squared minus x minus 20. And then that is factorable. Let's see, 5 and 4, I believe. So it's going to be x minus 5, x plus 4, 5, 10, 15, 20. Yep, that will work. So then I get two values. If x is 5, that will zero it out. And if x is negative 4, that will zero it out. But both of them will not work. Remember that the argument inside your log has to be positive, guys. So the only one that will work is the 5. the negative 4 will not work. Not because it's negative, but because if I insert it in here, you'll get a negative. Negative 4 plus 3 is negative 1. We can't have a negative argument. Negative 4 minus 4 is negative 8. We can't have that. So this is the only true one, guys. Cool? I hope that made sense. So log the expression on the inside. Who cares what the base is? Well, actually, we do care what the base. But for now, you're good. The argument in here must be positive. The argument. The whole expression. When we put the x values in. All right. So here we go. Another one. So I have a minus. The bases are the same. It equals negative 1. So it looks like a good demonstration of due quotient. So I'm going to write 2x minus 1 over x plus 2 equals negative 1. So I'm going to go 2 to that power equals that expression. So I'm going to write it up here. 2 to the negative 1 equals 2x minus 1 over x plus 2. And then I can hear you guys. Some of you guys are saying, Chavez, I need a calculator. There's no way that I can do this. Yes, you can, guys. You don't need a calculator for this. 2 to the negative 1 is just a half. So 1/2 equals 2x minus 1 over x plus 2. And then look, I have a ratio equals, and I have another ratio. You can just cross multiply, guys. So I'm just going to cross multiply. See? So I'm going to have the expression x plus 2 equals 2 times 2x is going to be 4x. 2 times 1 is going to be minus 2. And now I'm just going to solve for x, guys. I'm just going to move this x to the right and that 2 to the left. So minus x, and then plus 2, plus 2. So I'm going to have 4 equals 3x. And then when I divide by 3, I get x equals 4 over 3. And it looks like it would work because if I plug in a 4/3 into my expressions, I do get a positive argument. I do get a positive number in the inside. All right, let's keep going. So on this one here, guys, it says ln x minus 9 to the 4th power equals 8. I should have done a better job. That is to the 4th power. If you see an ln to the 4th power like that, that means that it's ln that is being to the 4th power. So that means that, which is totally different than what I have over here. All right, that's just something for you guys to know. All right, so here we go. I'm going to bring that 4 to the front. That's your power rule. So 4 ln of x minus 9 equals 8. I'm going to divide both sides by 4. So I'm going to have ln x minus 9 equals 2. And we haven't really talked too much about e, but in order for us to bring that down, well, you know what? Since I haven't talked about e, I'm not going to go there. I'm just going to change the ln to log base e. So remember that property. It's right, where are you? It's right here. So I'm going to change it to that property, guys. So here we go. So I'm going to write log base e of x minus 9 equals 2. And now we're ready. So I'm going to write e squared equals x minus 9. And then I'm going to add 9 on both sides. So x equals e squared plus 9. Since e is already a positive number, when I square it, it's still positive. Plus 9 is definitely a positive. So yeah, that argument is definitely a positive argument. And you're good. If you want to test it out, you can plug it in. Side note, ln of e is just 1. So yeah, let's test it out. So I'm going to move the 4 to the front. I'm going to start right here. 4 ln, and then x was e squared plus 9. And then bring that down there. Minus 9 equals 8. Let's see. If you drop the parentheses, these go away. So then you have 4 ln of e squared, and then bring that 2 to the outside. So 4 times 2 is 8. So you get 8. And yeah, you do. It works, guys. All right, let's keep going. So we have ln x plus 2 plus ln x minus 2 equals 0. Looks kind of interesting. Let's see what's going to happen. Ln x plus 2. Oh, it's not going to be a fraction. It's going to be a product. So x plus 2 times x minus 2, and all that equals 0. Again, we're going to transform the ln to a log base e. If you know what's up, you can just go e, and you'll already get your answer. Log base e of x plus 2, x minus 2, equals 0. E to the 0 is equal to that expression on the inside. So I'm going to write e to the 0 equals x plus 2x minus 2. Hopefully you recognize this is the difference of squares, guys. If you don't recognize that it's a difference of squares, just go ahead and FOIL this out. So you're going to get e to the 0 equals x squared minus 4. E to the 0 is a 1. So 1 equals x squared minus 4. Move the 4 to the other side. So 5 equals x squared, and then square root both of them. So x equals the square root of 5. So there it is. It can't be the negative square root of 5, guys, because negative square root of 5 minus 2 is going to be a negative argument. So just that one. All right, we got a few more. Okay, so I have a plus here with a half. So let's see, log base 3 of 1/8, and I'm going to bring the half over. So I'm going to write plus log base 3 of 64 to the power half equals x. All right, this right here, remember, laws of exponents, this right here means square root of 64. So the square root of 64 is 8. So log base 3 of 1/8 plus log base 3 of 8 equals x. All right, so let's see what this is right here. So continuing, I have a plus there, so that means I can multiply them. Log base 3 of 1/8 times 8 equals x. So then that turns to log base 3 of 1 equals x. And log, who cares what the base is? If it's 1, it's always equal to 0. So x equals 0. Very good, guys. Let's keep going. This is kind of a funny one to me. I don't think it's very interesting. Yes, ln of e to the x is just x because ln, that x just comes to the front here. X ln of e, and ln of e is just 1. So yeah, it's not too interesting, but I guess let's just go ahead. Ln e to the 5th plus ln e 3, that's the same thing as 5, 6, 7, 8. Ln e to the 8th. I wouldn't necessarily do it that way, but that's fine, which equals 8. So all that just equals 8. All right, I think this is the last one here. So I want to know what this is. This, notice it's 1 over e to the 5th. If you bring this up, you get ln e to the negative 5, which equals x. And then that negative 5, you can just right there in the front. Negative 5 ln of e equals x. Ln of e is just 1. So x equals negative 5. All right, guys, try the delta math out. Let me know if there's anything crazy going on. And if there is, we'll talk about it over the Zoom, and maybe we'll create another video. And yeah, so let's just take care of business. And let me know if everything seems all right, guys. All right, talk to you guys later.